Hey you guys, today we're going to analyze the motion of free fall. I'm sure you just watched a video of me dropping a lot of different objects to show you that they all fall at the same rate, and now we're actually going to calculate that rate at which they fall. So I have inserted a video into a motion analysis program called Logger Pro. So the first thing I want to do is to set my scale, and that's why I made sure that there was a meter stick in the picture so that the program itself can see what 1 meter is. Okay, and it looks like I might be off a little bit, so hopefully it's not too bad though. Next we're going to add some points, and we're just going to analyze this motion kind of frame by frame, and you'll be able to see what is going on. So I'm going to kind of go frame by frame here. Okay, you can see my hand is no longer touching the basketball, so I'm going to put a point there, and I'm going to try to put a point at the center of each frame. And you can see here in the background it's collecting some data, trying to move in the middle of the basketball each time. Now if you'll notice, what's going on with these spaces is they're getting bigger and bigger. Now something happened here. I think I skipped a frame right there, but that's okay. Between each frame, it's getting bigger and bigger. Okay, until the moment that it reaches the ground. So we're going to be I'm going to move this video out of the way now. But the fact that these distances are not the same, that should tell you that the object is speeding up over time, or it is accelerating. We saw in our constant velocity unit that when those spaces were the same, like with the Doom buggy, the object was moving at a constant velocity. But now we have an object in free fall, so it's actually accelerating. So I'm going to move this video kind of out of the way here. All right, and we get some nice motion. Now, first of all, let's see what's going on. So the red dots here they say X, so that would be a horizontal position. And notice our horizontal position is not moving. This ball is not moving horizontally. It's only moving vertically, which is the up and down direction. So I'm going to see if I can get rid of this. Okay, I was able to get just the vertical motion here. That's up and down, and that's what we're interested in since the basketball is moving up and down. And we can kind of see that this is curving. Now, if you were to look at your cheat sheet, this would be speeding up in a negative direction. Notice how it's getting steeper. And let me show you what I mean by instantaneous velocity. So here, if I hover over these different points, it's drawing a tangent line. And you can see how this tangent line actually gets steeper and steeper. Okay, so another thing I want to show you is we're going to look at a curve fit. And here, this is quadratic. You can see how nice the quadratic function fits with our data here. So I can click try fit. You can see for the most part it looks like a nice downward curve like we saw on our cheat sheet last week. So there we go, that's kind of cool. We see an equation now. The position equals a number times t squared, and that number is really important. We're going to talk about that a little later in our notes. So now I'm going to get rid of that fit, and I'm actually going to graph the y velocity, show you what that looks like. It's a little sloppier. I don't need these tangent lines anymore. Let's see. It's a little sloppier, but we can do a better linear fit there. Okay, now we notice that we have a slope of about -10 meters per second. Notice the units here. That's meters per second every second. So that's showing that the speed of the basketball is changing by about 10 meters per second every second.